Where they come from. So, well, good morning, everyone. My name's Dean Barnes. I'm with Emerson. I live in Baton Rouge, Louisiana. I cover the Southeast United States for Emerson for the pressure management products. So I cover Louisiana up to Virginia, and been with started out with Anderson Greenwood. So I've been with the company for 32 years. So when we, talk about our products, we have high pressure products under Anderson Greenwood Crosby. We actually do have some low pressure products under Anderson Greenwood. When we start talking about pilot technology. And then our mainstay for tank products is the Inardo brand and the Barrick brand. And both those are manufactured out of Tulsa, Oklahoma. This is my counterpart, Mo.
Hi, everyone. My name is Mo Fazl. I'm the North America Business Development Manager for downstream tank and PRV monitoring. Been with Emerson since about 2018. Here to talk about tank today.
Yep, talk about tank products. So we'll go ahead and kick it off and get started. There's a lot to think about. When you think about a tank, it's really its own environment, right? When you got a lot going on that tank itself. There's a lot of regulatory, environmental concerns with the products that are up on top of these tanks. We'll say just in general, when you're talking about very low pressure type products, there's leak rates on these, and some of these devices can leak as early as 50, 75, and the tighter you get, obviously, the better you can control the pressure within that tank. So, of course, safety, undetected failures of any of these devices, cost becomes a big one because one, you have this tank, you have this environment that you need to maintain, the in and out breathing that you have. Also, when it comes to the devices themselves, there's not a lot of codes or standards around the devices to set up your testing or your maintenance schedule on these type of devices, right? So if you think about a high pressure valve, right, it's built to ASME. There's a code stamp on there. There's the national board that puts out the NBIC that has a lot to do with, your testing, documenting that testing, determining when you have to do a preventive maintenance on that device to ensure that it's always reliable and functioning properly. So you get into API 576, the inspection of pressure relief devices does have some general information around, pressure vacuum and things like that, but on the whole, it's not as written around like the national board and the ASME. So when it comes to maintenance, it relies a lot on yourself to determine, through your data and through the history that you've collected on that valve, when maintenance needs to be done to ensure that you're going to meet that. Of course, keeping product quality is extremely important, and product loss is nothing but just dollars being lost through product, right? And typically, these products we're talking about, are going to be our overpressure protection and our underpressure protection over here in our chart. So when you're in the middle part right there, right, that's where you're steady at and maintaining your normal operating pressure in there. But of course, as we have, an outbreathing event, we're pumping into that tank, we're beginning to fill, and we don't want to overpressure that tank. We have to have some way to eliminate that pressure, or as we draw product out of the tank, or have, ambient conditions create. We have a vacuum inside that tank. We have the products that do that. So right there in the middle, all the way from the green to the blue, you're talking about, on the in-breathing side, blanket gas in-breathing, oxygen in-breathing. On the out-breathing side, you're talking about, vapor destruction and recovery, or you could just be venting off the atmosphere. So a lot of these products, again, are there for and sized and selected based off of your pump in, your pump out rate, your ambient conditions that you may have, the other type of systems you may have on there, like a blanket gas or a recovery type system. Because when you think about the overpressure protection side, these devices, they open and they have a certain amount of overpressure to get to their full lift to release that pressure off that tank and maintain it in a safe condition. And on the vacuum side, to make sure that we do not implode, because at the end of the day, once you get into, the red, now you're talking about your standard day-to-day operating type devices. You're going into an emergency type of device. So you could have a pressure vacuum vent that's there, again, for your pump in, your pump out rate, your ambient conditions and everything that you may have. But say you have a fire capability out on side of that vessel, and now all of a sudden, that device isn't large enough. So you're gonna have that device up there to handle the everyday type of overpressure and under pressure events. And then for a fire case, you may have an emergency vent. An emergency vent starts at 18-inch, 20-inch, 24-inch. And that really gets you into this high volume release out of there, because obviously you don't want that overpressure to happen. So sometimes you may utilize the exact same equipment depending on what the requirement is for release, but you never obviously want to get to the purple on this chart up here. You never want to get to an imploded tank where you're sucking it in because you didn't have enough fill gas or atmospheric pressure to reload, or also a tank rupture where you have too much pressure that can occur. So in this environment on a tank blanketing regulators and a vapor recovery, the purpose of tank blanketing is really to maintain, your product inside of that vessel. It removes contaminants and anything getting into your product, so it creates product integrity. Blanketing relieves vacuum conditions, by introducing a media. Typically, it's going to be nitrogen. Obviously, you can use some other type of inert gas or the same type of gas that the product may be in there. Blanketing is really good for environmental because if you have overpressure events, you typically are releasing the blanket gas, in this case of nitrogen. When you think about the regulator, though, you have to understand where you're going to be setting your regulator and where you're going to be setting your overpressure protection devices. Because as we, create a vacuum and the regulator opens to reload that space and to bring that tank back up, now you have a device that has an opening on it based off of its setting, right? So just terms like lockup, where that is on the regulator is as the regulator's opening and flowing, and we're bringing the tank back to the normal operating pressure, the regulator doesn't just shut off right at that pressure. It actually increases the pressure above the tank, which could be too close to our overpressure protection device. And what it is when lockup occurs, that means we've brought the pressure back up into a safe condition in the tank itself. Now the regulator is actually closed off. So the regulator has no more flow, but the pressure now is sitting just above the set point of that regulator, right? So if we have overpressure protection devices, where have we set the overpressure protection device? Because again, you're not wanting to lose your blanket gas. It's there to maintain the integrity of the product and maintain the environment and the pressure of that tank in a very safe condition. So what to consider, what is the lockup in relation to the pressure vacuum relief device and their set points? And then the installation, just the location of that device itself, right? And where we're measuring on top of the tank, and where we have that regulator open and feeding pressure back into the tank itself. So when we think about pressure vacuum relief devices, at the end of the day, it's a very generic type of overpressure protection device. Maybe generic's not the right word. It's a simple kind of overpressure protection device. So over here in a little example. So on the pressure side, of course, we're preventing a tank from, overpressurizing and creating, damage to that tank. But looking at this as a combination pressure vacuum vent, one directly to atmosphere, one that could be piped away. So over here up on the top, we have underneath our pallet assembly. So this little T or this little cross right here would be a pallet assembly. It'd be sitting down on the nozzle. As our pressure increases in our tank, right, we begin to push up against the weight, against that pallet assembly. We create lift as we reach the set point. As we have overpressure or pressure accumulating in the vessel, we're going to create more lift in the valve to create our flow areas so we can evacuate that pressure out of there. So in these operating characteristics, right, one thing about overpressure protection device, every one of them, no brand name, no type, they all actually leak prior to the actual set pressure, right? We utilize the leakage coming across that fixed nozzle area to expand out to the larger surface area to help us create the lift it's set. But as we have flow through it, that additional area allows the device to stay into its lift state, right? Because as it's open, we have a pressure drop occurring across that nozzle. So we need that larger surface area. So it's kind of hard to see in here, but we got a little nozzle area right here, but the pallet's just a little bit larger, and that's going to give us the ability to maintain that lift. Now, what is important about these is where your seat tightness needs to be. It's a standard, again, about 75% there's allowable leakage. There are products out there, we offer some that we call an enhanced type device, gives you a much tighter seating, so you have less product loss. In this case, if you had a blanket gas, you would be able to maintain that blanket gas in there and maintain a safe condition on your vessel itself. So you have less product loss. So at the end of the day, what to consider the set point relative to the lockup of the blanketing regulator, right? That's what we were just talking about when we talked about the regulators. And the total tank pressure that exists during normal venting in relation to the emergency or the emergency pressure relief device. On the vacuum side over here, to ensure that we don't implode a tank itself, so we align the pump systems, we're drawing product out of there as that liquid level drops, that vapor space goes under a vacuum, right? It's actually not the vacuum that creates the lift in the vacuum breaker. So we do have a vacuum in the body of the valve, right? So now I have my overpressure, my pressure protection down against its seat. So we're pulling downward with a vacuum. On the back side of this pallet, we do have a vacuum, but really we're referencing atmosphere. So now our atmospheric pressure is what's creating the lift. And as we create the lift with a vacuum in the tank, we're able to allow that, atmospheric pressure to reload into the vessel. So again, we do not implode or suck in a tank to create problems. So P-patches can also be overpressure protection devices, right? Typically, if you think about a P-patch, or just a hatch, you might look at something like this just as kind of a lockdown. And what that does is it gives you access into the tank, it gives you a visual inspection inside the tank, it gives you the ability to do sampling, depth measurements, whatever may need to happen. But also P-patches can have built-in overpressure and under pressure or vacuum protection itself, right? So within the hatch itself, you have a closing mechanism that seals off, and that's where we seal off. But when we're in the closed position, by setting properly the vacuum side, which would suck this pallet assembly in and will allow our product to escape out from that side of it. On the pressure side, we would push upward under this horizontal area. It would create lift, and that would allow flow outside that hatch as well. So again, these are pretty nominal in their sizing. You're talking about like a 6, 8, or a 10-inch type of a hatch. So you're not getting into the 12-inch or the emergency type of hatch products that are out there. So what to consider with these, are there venting devices on top of the tank? You want to know all the other type of products that you have up there, because typically what you're able to do is use the combination of the capacities of these different devices to meet your overall capacity requirement to properly maintain that tank in a safe condition, right? So spring-loaded devices give you a better seat tightness than like a dead weight or a weight-loaded type of device. Again, spring-loaded devices give you the ability to have an enhanced type sealing, really minimizing your leak rate during your normal operating pressure, and just giving you a better way to maintain system pressure within the tank itself. So we talk about emergency pressure relief vents. Now we're talking about really large sizes. We need to evacuate, pressure as quickly as possible. So we may have a P-patch, we may have, a pressure vacuum vent on there that handles a lot of our day-to-day pump in and pump out rate that's required. But if we have an emergency type venting requirement, typically a fire case, where if there is a fire case scenario out on top of the vessel, obviously that gives us a pressure increase that would require a much larger flow area to maintain the tank within a safe condition. So now we utilize those day-to-day products along with the capacity that would come out in an emergency vent. So the emergency vent, again, set pressure relative to the total pressure that will exist in the tank during normal operations. But the emergency vent should not open during normal tank operation, right? It's not there to handle that pump in and pump out rate. It's there to handle that worst case scenario, which we've identified as a fire case scenario to allow us to have that very much larger capacity requirement come out of there. So a lot of these devices, now sizing through sizing programs and things like that. But when you look at certain low pressure products, you really got to understand what their overpressure requirement is to get that valve into its full lift, full flow capability. Right. So typically when we're sizing a valve, a vent valve, depending on where your set pressure is on that device, you're going to have leakage prior to that. You're going to get up to some point where you're going to create lift. But some of these devices, believe it or not, they take up to 100% overpressure to reach their full lift capability. Now, if your tank design cannot handle that 100% overpressure, obviously that wouldn't be a device that you would use, like a weight-loaded device. Over the years, weight-loaded devices have changed quite a bit. There's some devices that modulate in their lift, full lift by 100% overpressure. There's devices today that will actually get you in full lift at 10% overpressure. And really that changes the way that we can size these valves. And now we can take credit for that valve being at full lift at 10% and having that full flow capability through it. And then of course, then you get into the other devices like a pilot operated valve. It could be a snap action, full lift right at set pressure. Typically, you'll see these in cryogenic type services. You'll see these on LNG type facilities and tanks like that, which can also modulate that type valve. So whenever you get into the sizing, the flow curves are very helpful to get an understanding of what the overpressure requirement is to get from there. But getting down to a specific type product, doing the sizing and selection through their their type of program gives you the best fit, the best selection for that overall application. I'll turn this over to Mo now.
Thank you, Dean. So like Dean was mentioning, right? So you have your set, which you need a significant amount of overpressure to actually get the valve relieving its full capacity, which is a concern because when you think about your devices, the more amount of overpressure required means the more amount of product out there. It means the less you're able to operate close to your set, right? So that's one issue. The other issue or the other main concern essentially in tanks is sizing. Because there's so many components on top of a tank, right? All the way from your hatch to your PVRV to your emergency vent, and like having for your regulator. So a lot of the times the issues, one of the most common issues you've seen is the sizing spread or the set pressure spread not done right, right? So like he was mentioning, if your lockup tail coincides with your PVRV set point or your pressure vacuum vent, your pressure vacuum vent's going to constantly be open and your regulator's constantly hooked up nitrogen. So you're just blowing nitrogen out, right? So understanding that spread is one of the most important things. The other side of it is like actually maintaining the valves and having a good maintenance cycle on it. Because tank products, the common trend around if you don't have a good maintenance cycle is it's out of sight, it's out of mind, right? You don't see it, these tank arcs are high, you're walking around the tank battery, but without any visible confirmation, no one goes up these tanks as often because it's tedious to get up there. You don't have visibility of your product. What condition is it? Is it physically good? Is it operating the way it's supposed to? Is it stuck open or not? So we'll talk a little bit more about that as well. But essentially our set pressure spreads is what's most important. Now, like Dean was mentioning, industry standard allows products to essentially leak at 75% of set. So once you reach 75% of what your full lift, what your expectation is, your product starts to leak. So our recommendation is, again, irrespective of product, if you have everything spread out to where your normal in-breathe and out-breathe is less than 75% of your next protection device, right? So you don't want your emergency vent, which is your last line of defense, to go off every time your PVRV does your normal in-breathe and out-breathe. So if we look over here, we have your lockup tail should be less than 75% of your PVRV set point. So you have room to like naturally operate and not losing product, or your product's not constantly like working to maintain your tank integrity. say a similar thing with your PVRV and your emergency vent set point. And then your emergency vent being a last line of defense needs to be set out in such a spread to where it's not too late before your tank either explodes or implodes, or it's not too early to where your PVRV, it opens every time your pressure vacuum vent does the relief, right? So like Dean was mentioning, our pallet areas are a little bit larger than the nozzle areas, right? So we have our standard valves, which, standard pressure vacuum vents, which take about close to 100% overpressure for it to go into full lift. But we've been able to come up with another product as well, which is the enhanced sealing product that Dean was talking about. We were able to achieve full lift in 10%. And the reason we're able to do that is because of the difference in the pallet type, right? So your standard valves, standard vents have a flat style pallet, but the quick lift or the full lift valve has a huddling chamber. So what happens is once pressure hits the pallet and the pallet is lifted, they're essentially, think of it as like indentations at the edges, like a inverted bell, right? So the pressure goes in there and pushes the seat up quicker. So you reach your full lift at 10% overpressure. So this right here, so you have your pressure side, right? And then you'll see the gauge move to the set point, and you see within 10% overpressure, the valve going at full lift. And then once your system stabilizes, your valve immediately shuts back down, right? And you'll see the similar thing on the vacuum end. And the benefit of this is your relief cycle is a lot shorter, right? So your valve is not opening longer, you're conserving product as well as you're emitting less, which is very important. So another option for your pressure vacuum relief vent is low pressure pilot valves. This is actually enhanced to the brand. And the benefit of having a pilot valve on top of your tank is these stay bubble tight to more than 90% of set, right? So you have zero leakage, more than 90% of set. And the best part about it is it reaches full lift in less than 10%. So you're saving on both ends. You're able to operate, get maximum operational efficiency, but at the same time, when you're relieving, you're not emitting as much out there. They are a little bit more complex devices compared to your normal pressure vacuum vents. So the recommendation of the industry study, usually adoption is on a critical process or a really expensive product or really toxic product. These solution is used. That way, you're able to understand that your valve fully opens when it's supposed to, and you only emit bare minimum because your release cycle is even shorter, right? Another benefit of having a pilot valve is when you reach closer to set pressure, based on the technology where it does not work opposed to weights or opposed to spring, it's more a force area at play. So the closer you get to set pressure, the tighter your valve gets, right? So it allows you to operate closer without having a leakage at all. And it is also balanced against back pressure. So you don't have any concern if it's being piped away someplace. You don't have to worry about any kind of back pressure that the vent is going to see. So it offsets your set pressure. So the way we tier it is you have a good, better, and best approach in terms of having your pressure vacuum relief vent in terms of your operating range and your emitting and your leakage, right? So in your standard, your typical conventional vent, you have your valve is closed, so there's no emissions. You have your normal venting range, where you have residual leakage, right? And then your vent needs to open to 100% overpressure for you to reach your full capacity. And then you have, essentially a reseat happening all the way back down. In your 10% full lift, you can set it a lot higher. So you have 10% full lift, you have your reseat, and that way it gives you all this additional operational advantage. But on the pilot, you have even better, right? So you can operate it even closer to set. You have your set point really close to where you need your set pressure really close to your design pressure. And you have your very your minimal relief cycle and a really fast reseat. So that additional operational advantage is really helpful in, first maintaining your tank integrity, second, in minimizing your emissions and getting the most out of your process. Any questions on that so far? Okay, we're gonna pivot a little bit and talk a little bit more about what I was referring to earlier, right? So when these tank top products are put out there, there's no visibility and no understanding in them. You have no real, clue of if it's working the way it's supposed to, and how is it working, how is it performing. Again, these are all mechanical products. They're really far out on top of a tank. Sending a person up every tank is really tedious and most of the times not practical. So one of the things we recommend is, having some kind of visibility or monitoring for these devices to understand these devices functioning better or not. So this right here is your tank top, right? So you see, again, it's crowded. There are a lot of devices, but what we could also do is we could have transmitters essentially attached to it to help you give visibility into the operations of it. Your standard PVRV during a normal in-breathe and out-breathe, we can attach a discrete signal so you can know if it's stuck open or stuck closed, right? Say you sized it's sized incorrectly, your lockup tail and PVRV set points are clashing. You notice that your pressure vacuum vent is constantly open. It helps give you more data to do root cause analysis. Having that additional visibility into how your product's actually operating helps you not only troubleshoot, but also optimize your process. So in addition to your pressure vacuum vent, we can also do it for your emergency vents, because these are really large in size, right? 18-inch, 22-inch, 24-inch. Say you have a significant overpressure event, and it's a weight-loaded emergency vent, and it reaches close to 90 degrees. All that weight is pushing downwards, and maybe your lid gets stuck open, right? But you don't want to send a worker up there to shut your emergency vent down every time you have an overpressure. So having a similar device, a discrete signal of letting you know when your valve is open, when it's stuck open, and when it's stuck closed, it'll be helpful in, again, optimizing the process, maintaining your asset integrity, and just having more visibility into what's happening on top of these tanks. This is another solution or another platform available as a software that could be adopted at sites where it ties into the discrete signal. The discrete signal essentially tells you open and close. Using the software, what it does is it helps automate your estimations and calculations of the amount being emitted out there, right? With regulations getting more and more stringent, there's a big demand of understanding how much is being vented and being able to give a quantifiable result. So the software right here, what it does is you essentially set up your tank, put in all the devices you have, put in your process conditions, and once you do that, it correlates a release event based off the discrete signal to the flow curves of the valve and the set pressure to give you an estimated release over that period in time. Because you have the time it started and the time it stopped, and it assumes close to 100% open, and it gives you a calculated release right there. So as soon as you get a notification that you had a release event, you get a quantifiable number of how much was released as well. So in critical tanks, which are required to have reporting done on them, this is a viable solution to adopt. So you have, that information available readily to you when the event does occur. This is another product that we have where what it does is it combines your high capacity full lift, so your 10% overpressure valve, with a flame arrestor, right? So say, for instance, there are fumes coming out of your tank and a lightning event occurs for whatever reason. It catches fire. This will essentially ensure that that fire doesn't travel all the way back into your tank. So it serves two purposes, where one is it's your 10% pressure vacuum vent, but the second is it acts as a flame arrestor, stopping the flame from traveling back into your product and causing an explosion, burning your product of your fines. So it's one of our latest products. So just to summarize everything we've spoken about today, right? Unlike your normal Section 8s and codes and standards for pressure relief valves, there isn't much, regulation or rule around normal venting and breathing for tank top products. Your PVRVs require a significant amount of overpressure to open, right? The standard weight-loaded ones, which are most common out there, They require close to 100%, so that takes out a lot of your operating leverage. Because of this, the PVRP must be set closer to the set point. Closer to the operating pressure and not to the set point. So again, you have your loss of not being able to operate close to set. The limit, right? 75% is kind of the rule of thumb between your application spreads. So when you're sizing it, making sure that everything is spread out within 75% of each other, so they don't coincide in the set pressure spread makes sense essentially. If the operating pressure is over 75%, then you would expect a lot more maintenance, right? Because there may be some scenarios just based on the operation and based on the set pressure spread, you're not able to reach that sweet spot. So you might need to compromise on one of the other products, but that would require constant maintenance to check on these products to make sure that they're good, they're not leaking, and everything's intact. And again, PVRV overpressure ideally should not exceed 75% of the emergency range. We've seen this happen more often than not, that the set pressures do collide out there. So it's just having that visibility and understanding it makes life fun. And that's all we got for y'all. We're out there in Emerson's booth. So feel free to stop by, have any questions for us. We'd be more than happy to help you out and answer any questions. Yeah.
What do you recommend for peat patches that become corrosive?
Like product corrosion or environmental. So, I mean, are you just talking about
Like where that seal could get broken?
yeah.
It would,
I mean, obviously it's your material thing for
Right.
us to look at. We'd have to discuss with you, obviously, what product it is, how it's being built up. Do you know if it's, I mean, we coat the springs, we have elastomers in there. We really have to talk to you about what your product is and the type of corrosion issues it would have. Obviously, what we would try to do is either coat or anything from like a nickel plate to, something that doesn't have weight. We don't want weight onto the hatch or anything like that, to a material upgrade.
yeah, it's just not how often it's happening. That's right.
In Louisiana, I deal with a lot of offshore stuff. So it's amazing. 20 years ago, everything was carbon steel 3-coat paint. Now everything is super duplex, Inconel, Ascolloy. So it's just changing the material to meet the corrosion.
What about dirty products like crude oil interfering with the seat and the pallet setting?
Yeah, I mean, obviously these work on the vapor space. So you're looking at just vapor carryover or something like that. If it's an overfill scenario, we recommend pulling it, cleaning it, doing everything you can.
Yeah, we do a PM on them, but it seems like it's always.
Always gets, so.
Yeah, I mean, even if you don't have overfill, you got the vapor just kind of always.
Yeah,
sticks.
always sitting,
starts to build
right
up
there
on top
against
of
the
it.
pallet. Yeah, if you get the buildup and start pushing the pallet, you get leaks. Is there anything to resolve that?
Well, not something that's simple, but it's more inspections, it's shortening your frequency on
On the PM?
yes. See, that's kind of what like even the National Board and API 576 talk about that. So everything's about building the history, right? We design and put these into different industries on different products and stuff like that, but every one of them operate a little bit differently based off of the processes that they're on. So those documents talk about during your inspection, you can document everything that you found. And then the next time you do it, you compare that documentation and you just build that history, and that history should allow you to either shorten or extend out the preventive maintenance cycle. Make sure that you don't run into this issue.
We have our
Yeah,
group that does our PM on it, document everything. And
yeah.
we built probably 2 years of history since we started.
So that's a great way to just go back and keep reviewing. Saying we've had this problem every year, so why don't we do a 9-month review and really start to catch where it's where it's happening, and that's where you start setting your preventive maintenance cycles to shorten.
So there's really no PVRB that would resist that.
I mean, again, coatings and things like that, but,
Yeah, you can get your pallets coated with certain material.
if it's a horizontal position, like in those hatches where it's set, if it's setting on there, then the material doesn't matter. Your product's just setting on there. Right?
Yeah,
Yeah, so that's more in the design of the valve. But that can change.
thank you.
Oh, yes. Good question. I mean, like he said, come by the booth. We actually have a test demo on some high pressure stuff that's got, we got everything from, you know, the bellows leak detection to, the DP transmitter showing opening and stuff like that. We can do it.
Do a demo for y'all. Yeah,
Yeah,
so we
yeah.
actually have a DP transmitter on the high pressure pilot here. The same technology is available on a low pressure pilot, which actually gives you indication of lift percentage. So every time when you're tank, if you have a high pressure pilot and you have a pressure release event, you can actually be able to estimate your lift percent and you'll be able to correlate that to flow because you have flow curves. You get a lot more accurate information of, you know, how much is being released every release event you have. And we have quite a few customers who've adopted it on actually tanks on low pressure where they've adopted the monitoring technology to understand better what's going on. So because you know, the low pressure pilots are available both in pressure and vacuum. So you can have, you know, either the internals of the pilot itself work on the vacuum end, or we have a vacuum pilot that helps deal with your vacuum with the vacuum set pressures. We're able to monitor both if required, right? So just if you have critical applications like that, potentially maybe we could discuss the application to see if a low pressure pilot could work in that scenario. If it could, then you know, you'd have more visibility, you could have this additional information
See,
seen.
our integrity department's actually in charge of the TBRVs.
Okay,
I'm the LDAR side of it,
gotcha.
and they're to save us money.
Fair. Yeah.
I could go back and shake them. Hey, we need something better.
Yeah,
Yeah.
yeah. I mean, it always, once you have timestamp data, right, that always helps to understand what changed to cause that to happen. And once you have that more data, you at least have a direction to go towards, right? So more visibility is always better.
Yeah, if I can basically feed that department some good information, maybe we can change that direction. Put something better on there, but I'm just guessing there are atypical PBRVs on there.
Probably. I mean, it's the most common one.
Yeah.
Right?
Yeah,
I mean, maybe if it helps with the enhanced skinning, at least the operational range, things like that, maybe that could be something, right? So, you know,
at least hit the troubled areas.
exactly. It all comes down to that, right? You have your normal operation, but you have critical, you know, and bad actors. You always want to tackle those first, then eventually. Like, normal operation.
I agree.
Critical and bad actors.
Yeah, our gas blending tanks, those are quite a number of big battles.
Yeah.
All right, so.
It's 7 minutes back in
everyone.
time.
So Jim, maybe get Mo's information and send us, if we'll get back.
Yeah.
I could pester the integrity department.
Yeah. That'd be great.
Thank you.
Thank you.
They're not gonna like me, but, you know. Yeah, actually, they're pretty receptive. It's people they have to feed
Yeah.
the